ready, and I just want to show you the example. And if you think it's okay, then I can go like write more about that. So the example I have here is the original prompts, the prompts that has been like the characters has been shuffled, and another one that the character has been added. So two types of adversarial adjustment. And then the output, we have three outputs, and I put those three outputs into the sentence embedding models, and I have like three vectors. So to visualize the vectors, I use PCA to like reduce the dimensions, and this is very simple, but basically you can see that vector 1 and vector 2, they are similar because the output also in the text also kind of similar. So it's the pig leader in Animal Farms was named Napoleon, and then the name of the pig leader in the novel Animal Farm was Napoleon. So these are the two vectors for those two outputs. But there's one output that GPT wasn't be able to understand the questions, and that the vector 2, and you can see that it's way up here. And also the cosine similarity also show that between vector 1 and vector 3, so these two over here, the cosine similarity is about like 0.9. And with this one way over here, compared to the original prompt, the cosine similarity is like 0.07. So that's how I analyze like one example. Do you think it's okay, or do you think should I analyze it any other ways?
So the two different prompts, can you tell me again, what are the two different prompts?
Okay, so there are three different prompts actually. The first one is the original one. In novel Animal Farm, what was the name of the pig leader? So it's a questions. And the second one is the same questions, but there has been 7 characters shuffled, so change the position of 7 characters. And that the output for that second one is a vector 2 over here.
Yeah.
And the third question was the same question, but there were 7 characters added to the original prompt. And the output is a vector 3 over here. Yeah.
And how do you get these vectors again? How do you turn these texts into vectors?
So I take these prompts to the GPT models, and then the output, I put the output through sentence embedding model. And that sentence embedding models generate like multi-dimensional vectors.
Yeah,
and
but
that's when
you generate these embeddings you generate for the responses. So there is no what you show here, these vectors. There's no ChatGPT involved, as I understand.
No, but GPT take these input and then it generate the output, and I embed the output. So these vectors like represent the output, not the input.
So these vectors are not the embeddings of these three different prompts.
Yeah, no, it's the embedding of the three different output from these prompts.
Okay, but it reflects nicely the similarity between the prompts. So it would be interesting to also see the embeddings of the prompts themselves.
Okay, embedding of the prompts.
Yeah.
Yeah.
This is what I had in mind. Very good.
Okay, so embedding of prompts. If you have no other comments on this, like, can I have other question?
Yes, please.
Just to check, because the other time you also told me one problem is that GPT it learns from the previous previous question. So I need to look into that, and the answer is quite simple because GPT API is stateless, so it does not learn from any previous run or anything. It's different from ChatGPT. So is that answer like already justify, like, do you need to go even deeper or?
No, it's good. But if you could make a sanity check. So for example, when you scroll up, so if you do this, what you showed here, these conversations, repeat it in a for loop 10 times and see if 10 times you get exactly the same output from ChatGPT.
Okay. Yeah.
You know,
So
trust is good, but control is better.
Okay, generate. So I have put an example here. Okay. Yeah, I think that's pretty much it. All that I have
Very nice
for
work.
now.
Yep.
Okay. Thank you.
Thank you.